This is problem number 4 on the practice problems for test number 2. For the parabola y equals 2x squared minus 6x minus 8, do each of the following. A, find the coordinates of the x-intercepts, if any. So to find the coordinates of the x-intercepts, we know we're going to let something equal 0. That something is the y value. So let's go ahead and copy our original equation, but instead of the y value, we're going to put 0. So now the goal is to solve that equation. We're probably going to end up factoring, although you could certainly just use the quadratic formula from here. One thing you might notice is that there's a common factor you can pull out of all 3 terms on the right-hand side. So what number goes into all 3 of those coefficients? It's a 2. And so we'll go ahead and factor that 2 out of everybody. And now I'm going to try to factor the thing in the parentheses, which is easier than the original. So factoring the thing in the parentheses is probably going to end up looking like that. Pause the video if you want to take a moment to find it, then come back when you've got it. So my 2 factors are x minus 4 and x plus 1. We're going to use our 0 product property to set each of these pieces equal to 0, including the 2. Okay, so I'll jump to the middle one. Here we get x is 4. Over here, x is negative 1. Over here, 2 equals 0 is ridiculous, so there are no solutions that come from that 2. So we've got our 2 x-intercepts at 4 and negative 1, and so we'll just write down the final answers as coordinates, ordered pairs. When x is 4, y is 0. We started with y equals 0 over there in blue. And when x is negative 1, y is also 0. So here are our 2 x-intercepts. Part B, find the coordinates of the y-intercept and the point symmetric to the y-intercept. Okay, so to find the coordinate of the y-intercept, we're going to let x equal 0. So again, we're going to copy that original equation. It's underlined in purple, but we're going to change all the x's to 0. So the y stays as it is. X's all become zeros. And doing the arithmetic, just about everything drops out, and we get y equals negative 8. So that means that the y-intercept, there's a negative 8 for the y, 0 for the x. So that's the y-intercept. And to find the point symmetric to the y-intercept, we actually can't do that just yet because I think we first need to know where the vertex is. So that question's a little bit out of order. Let's hold off on it for just a moment and jump down here to part C. Part C says find the coordinates of the vertex. So we're going to do this in 2 different ways. So one way you can find the vertex if you already have the x-intercepts is to just do something to those 2 x-intercepts. So I'm going to write down the x-intercepts are at 4 and negative 1. You can see them in red. So what can we do with those 2 numbers to find the x-coordinate of the vertex? We're going to average them. And so it's easy enough to average these 2 numbers. They're quite nice numbers. So the x-coordinate of the vertex, that's how I'm going to denote it, is just the average of 4 and negative 1. So we're going to add 4 and negative 1 and divide by 2. So the x-coordinate of the vertex happens at 3/2 or 1.5 if you prefer. Now it happened that the x-intercepts here were nice numbers, so it was easy enough to do this, but they could be quite messy numbers, and maybe we wouldn't want to do the average. It could be the x-intercepts aren't even real numbers. Turns out you can still average them, but we won't get into that. Let's go to method number 2, which maybe is a little bit better because it doesn't rely on knowing anything about the x-intercepts. So better is to use a little formula that gives you the x-coordinate of the vertex, and that formula is negative b over 2a. That's just a small part of the bigger quadratic formula. So let's go ahead and start plugging in the a, b, and c from our original equation. So coming way back up here, Remember, a is the coefficient, the number touching the x squared. B is the number touching the x, including that negative sign. C is the number sitting without any x's, again, including the negative sign. So B is -6, A is 2. So let's remember that as we fill in this formula. We said B was -6, so it's -6 divided by 2 times A was 2. 2 negatives upstairs make a positive. 6 divided by 4 reduces to the same 3/2 that we got up above. So that's the x-coordinate of the vertex, but we're not done. Notice it says coordinates, plural, so we still need to find the y. And we're going to do that by plugging in x equals 3/2 into the original. Okay, so we'll write it out. The original is on the top of your paper, so we'll put it here. Y was equal to 2x squared minus 6x minus 8. And all those x's are about to become 3/2. So pause the video here and do that arithmetic either by hand or with the calculator, and then come back when you've got it. Okay, so hopefully if we're doing fractions, we've got -25/2. If you're in decimal land, -12.5. So that means that the vertex has coordinates. So what we found were the x-coordinate was 3/2 and the y-coordinate was -25/2. Or write each of them in decimal, 1.5, -12.5. So either one of these is the coordinate for, or the coordinates for the vertex. And now that we know where the vertex is, we can go back and answer this question that was a little bit out of order. Up above, we were asked to find the point symmetric to the y-intercept. So maybe we'll just make a note. Can't do this until we found the vertex. Okay, so the y-intercept right there is highlighted, 0, -8. We're going to use that. So let's just go down below. And we'll continue on here on the right. So we found up above the y-intercept was 0, -8. And then the vertex we've got highlighted up there in blue. So we'll just write it here. The vertex is at 1.5, -12.5. And so we're trying to find the point symmetric to the vertex. So all we're going to do is see if we can kind of walk from the y-intercept at 0. How far do we have to walk horizontally to get to the vertex? We have to walk +1.5. So if we have to walk +1.5 to get from 0 to 1.5, then we're going to walk another +1.5, and that lands us on 3. So what we're finding here is the point symmetric. I was going to say the point symmetric to the y-intercept, but maybe it's better to call it the symmetric point of the y-intercept. So we found the x is 3, and to figure out the y, well, it's the symmetric point, so it's exactly the same y as it was before. So 3, -8. Probably the easiest way to think about finding that point is to just plot the points and draw the picture. And that's what we're asked to do here last. So let's start there. So the points that we found up above, first ones are the x-intercepts. We've got them right here, 4, 0, and -1, 0. So 4, 0, and -1, 0. Then we found the y-intercept. I think it was 0, -8. So that's this one. So we're going to plot 0, -8. We're going to estimate this a little bit down there, not the bottom. It's just the place where the parabola hits the y-axis. Then we'll grab the vertex. The vertex is circled here in black. 1.5, negative 12.5. So we'll go over 1.5 and then down, again estimating. So I think negative 12.5 is right halfway in between the negative 10 and negative 15. So that's the bottom point of our parabola. Now maybe finding the symmetric point for this guy right here is easier. So how far do we have to walk to get from 0 to the 1.5? Well, we had to walk 1.5 in the positive x direction. So then we're just going to take that and walk again another 1.5. And that's going to land us on 3. And it's the same exact y coordinate, so it's still negative 8. So now that we've got our 5 points plotted, all that's left to do is connect the dots with a smooth curve, our friend the parabola. Arrows if you're feeling fancy.